Okay. Ladies and gentlemen, we will wait a few seconds. I think everyone's kind of clicking in, so give them a few seconds and then we'll start. Thank you for your thumbs up. Okay, welcome. Our next speaker is Mr. Bhaskar Rao, a 25-year veteran in the field of crop production, operation, and management. Now he's going to speak to us about feeding the world. That's a big task. I mean, that I already feel the weight on my shoulder. So anyway, please welcome Mr. Bhaskar Rao. Let's all give him some emoticon applause. Over to you, Mr. Rao.
Thank you so much, Mr. Lawrence, for the introduction. My name is Bhaskar, as he has already mentioned, Bhaskar Rao from Veggitech. I represent a company called Veggitech in the UAE. We are basically into AGRITECH farming. We do lots of indoor vertical farms, controlled environment agriculture farms, and then we also are into organic farming here in the UAE and in most of the countries around the world. We are in 7 countries as of now. The topic I chose today is the hydroponic technology, basically into hydroponics only. Would be using this technology to feed the world. So let us see how we go about feeding the world with this technology of ours. At least it will be a good start as of now. So I'll be sharing my screen. Yeah, there you go. So hydroponic technology, the future tool to feed the world. This is how it goes. So let's try to think of how can we feed the world. See, by 2050, the world will be a home of around 9.7 billion people. We all know that. So we just have around 30 years to feed the world by making the production double. So we will be needing to produce 100% more food than today to feed the world. So you have got a small picture on the side which indicates the grains and the foods and the biofuels. So I'm sticking only to hydroponics. So let's go to the next slide and let's understand exactly how do you address the world hunger and how do we double up this global food production. Is it by farming more land? No, I don't think so, because that will give us only 20% of the way there. We need 100%, so we are 80% short. Or is it by raising more animals? No, again, maybe because that's not a very sustainable solution, because rearing of animals will increase the greenhouse emissions and it will be a hindrance to our resources. So producing food the old-fashioned way, as we have been doing from our forefathers' time, is that okay? The old-fashioned way that can feed all those people by 2050? No, not at all, says the United Nations. This is from the United Nations, not from me. It says, the Food and Agriculture Organization says no. So what is the solution? So we do have a solution here. The solution is the UN Food and Agriculture Organization has identified a very big solution. The solution is the word technology. That's why when I said we are an agro-tech company, we are mixing agriculture with technology. The technology that has been proven, it has been proven over a period of years through our labs, through our techniques, through our skills, that food can be produced with new technologies. New technologies involve skill development, involves mechanized commercial farming, the urban ag, precision ag, and the CEA, of course. What I mean by CEA is the controlled environment agriculture. So technology itself cannot help. We need to have all these parameters in place, and we need to have collaborations with all these parameters so that IoT is in place, we have all the mechanization in place, we have the skills in place. So that will collectively give us abundant food, affordable and safe and healthy and nutritious food. So let's come to exactly hydroponics, as my topic is on hydroponics to feed the world. Hydroponics is an art and also a science of growing crops without soil. It's basically soilless cultivation. Hydro meaning water and ponics meaning labor, which is virtually means working with water. So scientifically, hydroponic actually means nutrient-rich water being delivered to the root zone. So there is a timeline. So when did this hydroponics start? Let me tell you that hydroponics had started long back in 600 BC. We were doing the Hanging Gardens of Babylon, and then it moved on, and then we are in the present age. Just before that, during the 70s, we had tried to grow lots of hydroponic leafy greens with the help of NASA and Mars and all that. So this is just a concept saying that hydroponics is nothing new, but it was there in our history long back, but now we are adding technology to it and trying to get it more productive for our purposes. There are various types of methods of hydroponics. Okay, the methods of hydroponics basically are divided into two. One is something called solution culture or active hydroponics. The other is a medium culture or a passive hydroponics. Now, the solution culture uses a system whereby we grow crops in a solution, in a nutrient-rich solution, which is water. Okay, so this may be either static, the water may be static, not moving. It could be a continuous flow, which is NFT, nutrient film technology. It could be ebb and flow, flood and drain, deep water culture, DWC, which you use floating raft for cultivation. It is there in practice throughout the world now. Then you have the advanced technologies of aeroponics or fogoponics and rotary. So let's deal only with hydroponics as of now. The second is the medium culture. This is a passive hydroponics. In this system also, the nutrient-rich water is fed to the root zone, but the root zone is embedded in a media. There is a grow media. So the grow media is an inert media. It is not soil. The grow media could be rock wool, could be gravel, could be perlite, could be cocoa peat, could be the lightweight expanded clay aggregates, the round balls which you see in any of the indoor plants all around your offices, the LECA balls. So these are the few media or any other media that could hold water, and drain the water afterwards and make the nutrient-rich water available to the root zone so that the root zone uptakes all these nutrients for the plant growth. So we have different types of hydroponics. I'll just put you in a small nutshell the types of hydroponics. So we have a nutrient film technology, nutrient film technique, NFT, the deep water culture, we have a WIC system, we have the ebb and flow, the drip system, and aeroponics. Basically, all these use water as a grow media. And we do have pumps, we do have, and this could be enhanced, this could be enabled, it could be scaled up. This is just a schematic picture. It could be scaled up to a commercial level by implementing lots of automation, IoT, whatever you could add on to this. But the basic function of its working is this: an air pump, an air stone I'm showing you, but that is nothing but a dissolved oxygen. We should be having dissolved oxygen levels in the water which is being used for fertigation. Fertigation here means mixing of fertilizers in the water and supplying it to the root zone. That's called fertigation in hydroponics. So we have different types of grow media. So let me come one by one to the grow media, which is the passive hydroponics. So in this passive hydroponics, what we can grow is we can grow all types of crops in the passive hydroponics where there is a media to hold the roots. It could be wine crops, it could be fruit trees, it could be flowers, it could be floriculture industry, or even it could be berries, whatever, because we have a grow media. The basic attributes of a grow media are, it should be having a water holding capacity. The substrate should be having a high water holding capacity. That means it should be able to absorb the water. Then it should also be having the media attribute is drainage. It should be able to drain itself, so that there is, whenever a new water is replenished, this water drains off and you have the new water coming in with fertilizers in it. It should be durable, and it should be biodegradable, of course, and it should be supportive. It should be helping to anchor the plants. It should be helping to anchor the plants, so that these are all tall plants. They are the root crops and they are tall plants, so they would be able to grow long, and with the help of trellising ropes and all that. So the supportive aspect is very important for agro media. Coconut, as you all know, is a fiber from the coconut husk, which is very lightweight. It is the best material being used in the world today because it is biodegradable. Okay, it is 9 times the weight of it in water. It holds a lot of air. We should also consider the air and water ratio. The air and water ratio plays a very important role in having porosity, so that the roots have a lot of oxygen inside the media. It is completely eco-friendly. I'll just rush through all these slides. The next is the rock wool. Rock wool is from melting balastic rock and spinning this into a molten lava, which forms. It is used basically in hydroponics for NFT as grow plugs, or it could be also used as a grow slab for production of any sort of crop. It could be wild crops or any crop. It is not biodegradable at all. We have perlite. Perlite could be used individually. It's a volcanic material which pops up. It's like a popcorn. Basic idea behind is it helps in holding the water, number one, and also helps in aeration. So this media is used directly as a grow media, perlite, or it could be mixed with the coco peat in a particular ratio depending upon the crop and the grower. And then I was discussing about LECA. This is LECA, lightweight expanded clay, is an aggregate which is used in most of the people who are utilizing hydroponics as a growing substitute, but not very advisable. As per me, it varies from people to people. The best option for me is either you do it in coco peat perlite media, or you do it directly in NFT using water as a nutrient media. When we talk of hydroponics, there are a few challenges. There are lots of advantages. Everyone knows of its advantages, of course. So I would like to discuss basically on its challenges, so that you understand exactly where we stand and how to fight it out. It requires constant monitoring. Constant monitoring means you require a constant skilled guy who understands what's to be done. And putting up together a hydroponic system is not cheap. It's expensive. It's expensive in the initial stages. It is vulnerable to power outages. You should have a continuous supply of power. Okay. And if you're not able to control all your leakages or whatever systems you're employing, there is always a chance of your microorganisms being entering your system. So there will be a microbiological contamination of the water. And it requires technical expertise. As I told you that it requires monitoring, so it requires technical expertise. So skill development plays an important part in this challenge. And production is limited to certain crops, especially when you're talking of NFTs, when you're talking of nutrient film technology using water. Production is limited to a few crops. And because you are doing a closed circuit, a closed loop system, if a disease appears in the water, or if a disease is there around somewhere without properly taking care of things, then your whole system will be affected very soon. So we don't use soil, so you are not having that advantage of using soil as a buffer. So if you have a problem with your nutrient rich solution, water, maybe temperature changes or maybe fluctuation in the pH and EC, then the death of the crop occurs rapidly. So this connects back to your skill and monitoring. So why do we need to do hydroponics, and why is this playing a major part nowadays in the world's route? There is a big boost now for indoor hydroponic farming and CAA and urban ag. So let me just get back to you on a few statistics. It is very important for you to make decisions on why should we go about doing hydroponics. Now the global hydroponic market is expected to grow from 2 to 6.45 million, 226.45 US to 200, 724. That is, maybe 18%. 18% CAGR per annum growth rate is 18%. So just imagine the growth. So that's over the world over. And when you're talking of the world over, the average comes out. This is region wise, it's different. It comes to below that, 16 to 17. I have tabulated that. The smart greenhouse market. When I talk of smart greenhouse, I talk of IoT enabled greenhouses. You can see in the picture beside. So such greenhouses, the market is projected to 1.4 billion by 2020. That's, we are in 2020 already. So 1.4 billion market is there already. So by the next 5 years, it will be nearly double, 2.1. So we can just look at the impact of hydroponics. And coming back to India, with specific consideration of India, currently, India is importing around 85% of all its exotic vegetables. And this market is expected to grow at a rate of 15 to 20% per year. The exotic vegetable market I'm talking of. Okay. And the Indian hydroponics market is growing at a rate of, annual growth rate of 13.53% for the next 5 years, 5 to 6 years of projected forecasting. Let me talk about the Asia Pacific hydroponic market. It is estimated at 63 millions in 2018. And by the next 2 years, it will be 135 million USD. So that is 16.8% CAGR. The Middle East and North Africa hydroponic market, the part where I am now, it is going to go at 15.5% CAGR by 2030. So this is just a basic idea so that you understand exactly where we stand in the market. When we talk of producing locally and growing produce for the Indian market or for any local market in the sense, specifically emphasizing on India, and the food and grocery retail in India exceeds around 294 million US dollars. It represents 16% of India's GDP. Only the food and grocery retail. So the retail industry is expected to grow at US dollars 1.6 trillion by 2026, about 10% CAGR. So this segment, the grocery, food and grocery, segment, whereby we as a grower, as a hydroponic grower, feed this market, it constitutes 66% of the total revenues of the Indian retail sector. So the retail market is huge. It is a huge, big of chunk of cake. So everyone can dig into it. There's not a problem at all. And let me talk about organized market and the unorganized market to just make you understand exactly where we stand. This is relating to India. Its organized market constitutes only 3% in comparison to the unorganized segment that forms 97%. I'm talking about food retailing market in India. An unorganized sector is the sector which is generally the general stores, the corner shops you see in the market, the mom and pop stores, the kirana market. These shops at the corner of your street are more than 15 million. So you can just imagine the amount of growth in the organized market sector, which is still untapped. So the global organized food and grocery retail market, that was India. This is for the global. This chart will show you the global food grocery retail market. It is growing at the rate of 5%, not very high, but the figures are 17.3 trillion, which is a strong indicator of its growth potential in the years to come. So the organized sector includes gourmet stores, department stores, discount stores, supermarkets, hypermarkets, e-tailers as of now, and cash and carry formats. So two most significant trends emerging rapidly are, because of the expansion of imported food categories, the incremental popularity of gourmet food, high-end markets. So these contribute to such markets. So this segment basically it offers high margin to retail for high-end products. When you're putting in big money to produce hydroponic products, you need to cater to premium customers and high-end segment. That was my idea. So urban ag, we have too many participants in this industry as of now. Let me tell you very frankly that there is not much knowledge. There is not much understanding of the subject. It is still in the nascent stage. So you should be having to develop your crop production knowledge and expertise in this field to start up any sort of systems. It should be, it could be hydroponics, it could be rooftops, it could be warehouses, it could be in your cities, controlled ag, whatever. Okay. This challenge needs skill development. So it's a huge challenge for the Indian market to develop their skills. Statistics shows 41% of India's population is below the age of 20. So we have 365 million young guys there who could help us grow, who could help us understand exactly how to feed ourselves in the next few years. So the road ahead is, the adoption of food safety. I'm not talking of just producing food, but safe food, nutritious food with quality consciousness, so that we adapt it to the international standards of good hygiene practices, and that will be enabling us to, adhere to a stringent quality hygiene norms, thereby protect consumer health, prepare the industry to face the global competition, enhance product acceptance, and thus, these food safety and quality parameters could be easily implemented by using hydroponic cultivation, because these all factors are controlled manually, controlled physically by the expert on the field who is growing it.
Okay. Uh, so sorry to interrupt, but
Yeah,
we're running out of time.
yeah,
So, in fact, there are a lot of questions that I see fielded by the floor, but I don't think we have enough time because Mr.
yeah.
Bhaskar Rao has to go off to another forum. So, I thank you for your participation. A lot of you asked questions. Now, what we will do is that we will get back to you on some of those questions that you've asked. Someone asked about the presentation. We will make this available on the website. So be on the lookout for it, okay? So thank you very much for your time. So sorry to cut this short, but this is the end of the session. Thank you.